In this video we're going to be discussing linear functions or linear equations, more or less a continuation from example 2, not very different at all, just the questions worded a bit different, and instead of being given a table of values, now you're given a graph. So example 3, illustrated below is a graph showing a relationship between x and y. Draw in a trend line or line of best fit and determine an equation which best represents the relationship. So obviously the relationship is referring to the relationship between x and y. We have a graph, we've got some points on it, and what I've done is I've selected 2 points and put coordinates on it. I'll explain that in a second as to why I did that, but what it's essentially asking us to do first is to draw in a trend line. Now a trend line is a line which best represents the average, more or less the center line of all these points. Okay, so the center line of all these points. Now fortunately all of these points fall right on a straight line, or should do, or won't be very far off. So if I draw a straight line through, I often like to put little arrows on the end to suggest that that function goes on. So there's my trend line. It's then suggesting that we need to determine an equation which best represents the relationship between x and y, which is represented by that line in which we just drew in. So we're going to have to calculate the equation for this line. Because it's a straight line, we can use our general form for a straight line, which is our y equals mx plus c equation, which I've, like example 2, gone and listed as 1, suggesting that this is equation 1, meaning that if I have to refer to this, I'm just going to refer to it as equation 1 to save me some time. I'm going to have to find an m and a c value, the first of which, the gradient m, I'm going to look for, and define the formula to determine the gradient as y2 take y1 divided by x2 take x1, which, as in example 2 I explained, is essentially the rise divided by the run. I took these 2 points earlier because I need 2 points to substitute into this equation. The subscript 2 refers to the x and y for point 2, and the subscript of 1 refers to the x and y of point 1. Now I'm going to call this one here point 1 and this one here point 2. So when I substitute in for the x and y values of those 2 points, I get -4 as a y2 value, minus 0 as a y1 value, divided by 1 as an x2 value, minus x1, which is -1, thus why I've written -1, and again, like example 2, we have a double negative situation, which means we have to turn it into a positive, meaning we have 1 plus 1. And if I simplify that, I get -4 divided by 2, which I can simplify as -2. What I then need to do is take that m value of -2 and substitute it into equation 1, which is this. So we're going to take m equals -2 and put it into this equation. So where we see m, we're going to write -2. Thus why this equation is written here. I've then gone and defined it as equation 2. So if I want to refer to this now, I'm going to call it equation 2. Now we have to find the y-intercept, which is our c value. So what I've said is, to solve for c, substitute any xy coordinate into equation 2. Now the coordinate in which I've chosen is this one, and that was just one that I pulled straight out of the graph. When I do that substitution, so when I substitute these 2 values into equation 2, which is on the previous page, I'll quickly go back and show you where equation 2 was if you've forgotten. So I'm substituting xy here to give me this. I can then simplify this, which realistically means negative 2 times 1, which will give negative 2, and I can rearrange to solve for c such that c equals negative 4 plus 2, and therefore negative 2. Now I have my c value, I can substitute it into equation 2, which was the one on the previous page, to give us this. Now that there is the function. That is a straight line function defining the relationship between x and y. That is correct. I'm not suggesting that is wrong, but if you want to go a step further, you can actually factorize this expression up here, because you'll note there's a common factor of negative 2. Now that means I can factorize it outside a pair of brackets, and such that if I were to expand this here, negative 2 times x, it would give me negative 2x, and negative 2 times 1 would give me negative 2. So these two things are the same thing. So technically, if you were to have this as an answer, you are correct. But this one here is just showing me a little bit better communication with regards to the factorization. So both forms would be correct.